Let's look at polynomial and rational inequalities. Okay, so we are going to solve x plus 3 quantity squared times x minus 2 quantity squared is greater than 0. Now, there are different ways of solving inequalities like this. You do not need to solve them exactly the same way that I do, because I usually end up organizing things in a table. Tables help me organize my thinking. If you are familiar with a different way of solving these and it's mathematically correct, that's fine. Go with what you're comfortable with. Okay, so first step, write the inequality so that 0 is by itself on the right-hand side. Ours is already set up like that, so we don't need to really do anything for this first step. Step 2, find the real zeros by setting the factors on the left-hand side equal to 0. And I have already factored the left-hand side for you already. That won't always be the case, so sometimes you will need to factor it before you can set the factors equal to 0. But we'll start off by setting x plus 3 equal to 0 and x minus 2 equal to 0. I don't need to necessarily do x plus 3 quantity squared, because if I square root both sides, I'll get x plus 3 equals 0. Just like with x minus 2 quantity squared set equal to 0, if I square root both sides, I would get x minus 2 equals 0. I could go right to just getting the factors. So if I subtract 3 from both sides in the first one, I get x is negative 3. If I add 2 to both sides in the second one, I get x is 2. So I have 2 zeros. My zeros are negative 3 and 2. And I try to make a habit of writing them in numerical order, so from smallest to largest. So next, we will use the real zeros to divide the real number line into intervals. I'm going to have an interval. Since my smallest zero is negative 3, I'm going to have an interval that goes from negative infinity up to negative 3. Another one that goes from negative 3 to 2, which is the next 0, and then from 2 to infinity. To visually see what that's doing, if I look at a real number line and add my zeros, negative 3 and 2, I can split the number line into 3 sections. 1, which corresponds to negative infinity to negative 3, 2, which corresponds to negative 3 to 2, and 3, which corresponds to 2 to infinity. You usually don't need to draw the number line. I like to draw it at least when I'm introducing this so that you can visually see where these intervals are coming from. But if you line up the zeros so that they're going from smallest to largest, you normally won't need to draw the number line every single time. So these were our 3 intervals. I'm going to set up a table where we will choose a number in the interval. We will evaluate the left-hand side of the inequality. We will draw a conclusion. So our step is select a number in each interval to determine if the interval is included in the solution. So you can choose any number that are in these intervals. You do not want to choose an endpoint, because these intervals have curved parentheses, so the endpoints are not included. So for example, for that first number, I would not want to choose negative 3. But I'll choose some easy numbers. I'm going to choose negative 4. In my second interval, I'm going to choose 0. If 0 is included in the interval, it usually is a number that I choose. And for my third interval, I'm going to choose 3. Again, these are not the only numbers you could choose. I just chose some simple ones. If I put now, like my negative 4, if I substitute it in for x in the left-hand side of that inequality that we started on the last slide, I would get that the left-hand side, which was x plus 3 quantity squared times x minus 2 quantity squared, so substituting in, I would get 36 on the left-hand side. If I put 0 in, I also get 36. If I put 3 in, I also get 36. This is a coincidence. Don't think it's going to be like that every single time. But this is telling me that that first interval produces positive numbers, so does the second interval, so does the third interval. Okay, and our original inequality was asking where that left-hand side is greater than 0, which means we want positives. So that means we want all three intervals. And we can write our solution as negative infinity to negative 3, unions, let's see, a set union sign, negative 3 to 2, union, 2 to infinity. And this is my solution. Let's look at another one. Let's solve x cubed plus 2x squared minus 3x is greater than 0. Okay, so this is already with everything on one side, 0 on the right-hand side, but we do need to factor our left-hand side. I'm going to start by factoring out a greatest common factor, and here that would be x. So x cubed divided by x is x squared, 2x squared divided by x is 2x, negative 3x divided by x is negative 3. So I have x times x squared plus 2x minus 3. And now the part that's in parentheses, of course it's greater than 0, the part that's in parentheses can be factored. I'm going to use my x method. I'm going to put a negative 3 at the top, a 2 at the bottom. Numbers that multiply to negative 3 but add to 2, that would be 3 and negative 1. So I have x times x plus 3 times x minus 1, and that's greater than 0. Okay, so now that we've got our factors, let's set all of our factors equal to 0. So x equals 0, x plus 3 equals 0, x minus 1 equals 0. X equals 0 is already solved for x. In the second one, I will subtract 3 from both sides. I'll get x equals negative 3. In the third one, I'll add 1 to both sides, and I will get x equals 1. So I have 3 zeros. And if I write them in order from smallest to largest, I have negative 3, 0, and 1. So now I'll create my intervals. Negative infinity to negative 3, negative 3 to 0, 0 to 1, 1 to infinity. So I will have one more interval than I do zeros. Okay, in my table, I will also choose a number. I will evaluate the left-hand side. I will draw a conclusion. So the number I am choosing in my first interval, and again, you don't need to choose the same number. I'm going to choose negative 4. In my second interval, I can't choose my 0 because it's a boundary number. So I'm going to choose negative 1. My third interval, I can't choose an integer. I have to choose a decimal, so 0.5. And in my fourth interval, I'm going to choose 2. When I substitute these numbers into the original left-hand side, I will get, for negative 4, I will get negative 20. For negative 1, I will get 4. If I substitute 0.5 in, I will get negative 0.875. If I substitute 2 in, I will get 10. So that means the first interval is giving me a negative number. The second interval is giving me a positive. The third interval gives me a negative number. The last interval gives me a positive number. In the original inequality, I was looking for where it's greater than 0, so I want the positives. So that means this interval, the second one, and the fourth one. And my solution will be negative 3 to 0, union 1 to infinity. Okay, let's look at a third example. 3x cubed is less than negative 15x squared. Okay, so now we do need to move everything to the left-hand side so that we have 0 on the right-hand side by itself. I will add 15x squared to both sides, and I'll get 3x cubed plus 15x squared is less than 0. I will factor that. by factoring out a greatest common factor. It will be 3x squared. 3x cubed divided by 3x squared will give me x. 15x squared divided by 3x squared gives me 5. So I factored, I have 3x squared times x plus 5 is less than 0. Okay, now I want to set each factor equal to 0. 3x squared equals 0. X plus 5 equals 0. If I divide the first one by 3, I get x squared equals 0. Square root both sides. X equals plus or minus 0, but 0 is the same whether it's plus or minus. So basically, x is 0. In the second equation, I will subtract 5 from both sides and end up with x equals negative 5. So I have two zeros. My smaller one is negative 5. My larger one is 0. My intervals will be negative infinity to negative 5, negative 5 to 0, 0 to infinity. I will choose a number, evaluate the left-hand side, draw a conclusion. The number I will choose in the first interval, again, you can choose any number you want. I'm choosing negative 6. In the second interval, I'm choosing negative 1. In the third interval, I am choosing positive 1. If I were to substitute those in to this inequality to figure out the left-hand side, I would get negative 108 for that negative 6. When I substitute in negative 1, I will get 12. When I substitute in positive 1, I will get 18. And in my inequality, I am looking for, well, I have negative, positive, positive, and I am looking for where it's negative. So I want this first interval, and that's the only one. So my solution is from negative infinity to negative 5. Okay, let's look at another one. Let's solve x to the fourth is greater than or equal to 1. We will move everything to one side, get 0 on the right-hand side by subtracting 1 from both sides and getting x to the fourth minus 1 is greater than or equal to 0. To factor this, I'm going to recognize that x to the fourth is a perfect square and 1 is a perfect square, and I have a minus in between, so I can factor this as a difference of squares with two sets of parentheses. The square root of x to the fourth is x squared. The square root of 1 is 1. One of these factors gets a plus, the other one gets a minus. Now I can notice that my second set of parentheses I can factor again exactly the same way. The first parentheses does not factor because it's a sum of squares, which does not factor. But the second set of parentheses I can split up into 2. The square root of x squared is x. Square root of 1 is 1. One of these will get a plus, the other one will get a minus. And that is as far as I can factor. So I have 3 factors. To find my zeros, I'm going to set all of them equal to 0. So x squared plus 1 equals 0. X plus 1 equals 0. X minus 1 equals 0. To solve for x on the first one, I will start by subtracting 1 from both sides. X squared equals negative 1, but we can't get a real number squared equaling a negative number. This one has no real solution. It would be a complex solution, but remember we were dividing the real number line into intervals. So no real solution or null set, so we do not have a 0 from that factor. In my second equation, I will subtract 1 from both sides. X equals negative 1. In my third equation, I'll add 1 to both sides. X equals positive 1. So I have 2 zeros, negative 1 and 1. And my intervals will be negative infinity to negative 1, negative 1 to positive 1, 1 to positive infinity. I will choose a number in the interval. I will evaluate the left-hand side. I will draw a conclusion. So let's choose a number in the interval negative infinity to negative 1. I will choose -2. -1 to 1, I will choose 0. 1 to infinity, I will choose 2. If I substitute in -2, I get 15. And I am substituting it into here. So I'm substituting -2 in for x. -2 raised to the 4th power minus 1 is 15. 0 to the 4th power minus 1 is -1. 2 to the 4th power minus 1 is positive 15. So my first interval yields positives. My second interval yields negatives. My third one yields positives. And I am looking for where it's greater than or equal to 0, so positives and zeros. So that equal bar is new to this problem. So we want this first interval and the second. My solution will be negative infinity to -1, but here I am including the 0. So instead of a curved parenthesis, I will put a squared off bracket. Union. Now I want the second interval, and I'm also including that 0, +1, so squared off bracket, 1 to infinity. Remember, positive and negative infinity will always get the curved parentheses because they're not actual numbers, they're ideas. And that is my solution. So the difference here was having the squared off brackets by the -1 and 1 because we had the equal bar where we were including the zeros. All right, so those were polynomial inequalities. Let's look at some examples of rational inequalities. Okay, and our steps are very, very similar. First, we'll write the inequality so that a rational expression is on the left-hand side and 0 on the right-hand side. Okay, ours is already like that, so I didn't need to do anything different. Then we will determine the real zeros of the left-hand side. I'll do that by setting the numerator equal to 0, very similar to what we did with polynomial inequalities. And then we will determine the real numbers where the left-hand side is undefined. And this is where we will set the denominator equal to 0. So let's find the zeros first. I will set x minus 1 equal to 0. I will set x plus 1 equal to 0. And I did factor this for you. If it's not factored, you would have to do that step first. Solving these, the first one I will add 1 to both sides. I will get x equals 1. The second one I will subtract 1 from both sides, and I'll get x equals -1. So I have two zeros, -1 and +1. Now let's find the undefineds by setting the denominator equal to 0, so x equals 0. And that is already solved, so I have an undefined value at x equals 0. So that was step 2. Now we will use the zeros and undefined values to divide the real number line into intervals. So now I'm going to take all three of these numbers, write them in order, -1, 0, +1, and I will get, since I have three values, I will get 4 intervals. Negative infinity to -1, -1 to 0, 0 to 1, 1 to infinity. Okay, next step will be to select a number, like we did before, in each interval, evaluate the value of the left-hand side, and determine whether the interval is positive, negative, and part of the solution. So those were my intervals. I'm going to choose a number. I will evaluate the left-hand side. I will draw a conclusion. So I will choose -2 for my first interval, -0.5 for my second, 0.5 for my third, and 2 for the fourth interval. When I substitute them in, when I substitute in -2, I will get -1.5. When I substitute in -0.5, I get +1.5. When I substitute in 0.5, I get negative 1.5. When I substitute in 2, I get 1.5. This looks like there's a pattern, but that is coincidence because of this function and because of my intervals and my numbers that I chose. Don't expect to always get such a pattern. My first interval yielded negatives. My second interval yielded positive numbers. My third one, negative numbers. And my fourth one, no matter what number I choose in that interval, I will get a positive number on my left-hand side. Now, my inequality looked like this, and we were looking for the negative values and the zeros. So this first interval yielded negative values, and so did the third. And my solution, I can write as negative infinity to negative 1, but I'm including zeros. Is negative 1 a 0 or an undefined? It is a 0, so I will include it and square it off. Union 0 to 1. But is 0 a 0 or is my 0 an undefined value? It's undefined, so I do not include it. So it stays as a curved parenthesis. And it goes up to 1, but 1 is a 0, so it's included. So what's different here is that I might have a variety of things, of symbols, whether it's squared off brackets or curved parentheses, because here I am including my zeros, but not my undefined values. I will never include my undefined values. But if I have like a less than or equal to, like I did in this inequality, or a greater than or equal to, I will include the zeros. So I'm going to stop the examples here and continue some more examples in a part 2 video.